Hello, welcome to today's webinar on the programmable car. My name is Brian Mulloy. You can follow me on Twitter. My handle is landlessness. A bunch of the content that we talk about is there's an active group, a community on Google Groups called API Craft. There is another one which just recently got kicked off called App Craft, where the focus is more on the consumption side of APIs. This video and all the videos we create in this webinar series are available on YouTube at our YouTube channel, which is youtube.com/apogee. And the slides will be available on SlideShare at slideshare.net/apogee as well. This is a really exciting topic. It's one of my favorites. So when you tell folks that you're working on stuff related to cars, there's been so much abuse by the automakers. Sometimes it's like punching a bozo clown right in the face, because I think it started with Bill Gates when he compared software advances versus how the automobile was advancing with respect to technology. I think that, after a decade in Silicon Valley and now 2 years here in Detroit thinking about connected car and programmable car applications, there's a really different perspective that I think is really compelling. If you kind of look at what the car looks like today, well, back in the day, it used to look like this. This is how cars were built. And I think for a lot of folks, when they think about how a car is created and the technology in the car, it hasn't changed much. It's just about putting wheels on axles and attaching the axles to the chassis. But it's really progressed quite a bit since then. Cars are designed using virtual reality software. They are tested using simulators, which are made of a bunch of software as well. And to an increasing degree, the cars themselves are manufactured by the code that roboticists write that powers robots on the manufacturing floor. With the advent of electric cars, there's a lot of code that goes into making sure that the powertrain works in the way it's supposed to. In fact, I heard a senior executive at a car maker describe that most people think that they're actually driving their cars, when in reality what's happening is they're making gestures to the software, and the software interprets those gestures and figures out how to translate it to the automobile, whether it's how you're braking or how you're steering, and of course all the software that's in the infotainment center. So it's a really interesting time to be thinking about the automobile. In fact, recently Wired has this awesome article. I'm just going to read this. The amount of software in the average vehicle has grown exponentially. A typical new car has about 100 million lines of code. With the advent of sophisticated, cloud-connected infotainment systems, software has become a competitive advantage as vital to General Motors or Toyota as it is to Apple or Google. And the title of that article was called "The Next Big OS War is in Your Dashboard." So not to mention just the cars that we're used to today, but there's a bunch of progress being made with autonomous vehicles. This is actually a picture of a Lexus at the Toyota Research Institute just down the road from where we are in Detroit here. This is in Ann Arbor. And once this happens, the cockpit of the car will really transform pretty quickly into a focus on office productivity and personal entertainment. For developers who've been making apps for smartphones, and there are quite a few folks doing that now, whether it's for the Android or iOS or other platforms, and for folks that have been messing around with open source hardware through applications like the very popular Arduino and others like Raspberry Pi, the car is sort of a dream platform to start hacking on and doing cool things with. And what I'd like to do is just hop right into it and to talk about things from a couple of perspectives. One is the perspective of the application developer who is going to build an app for an automobile. And the other is talking a little bit about what the perspective looks like from the car maker's point of view. And then at the end, just make a couple quick conclusions. This is sort of an introductory idea about talking about the programmable car, but we plan to do a few more sessions on this in the future. So there are three core use cases when it comes to building apps with respect to automobiles. The first one is the idea of having a smartphone app within the car, meaning you have your smartphone, it's in the car, and there's some communication happening between the smartphone and the vehicle. The second is you have a smartphone app and you're somewhere away from the car or without the car. You can think of it as sort of a remote application scenario. And then the third case is the idea of building a head unit app, where you're actually building an app that runs right on top of the vehicle, taking advantage directly of all of the sensors and actuators that are in the car. So let's walk through each of these scenarios. The first is the smartphone app within the car. Here's an example of this. So this is actually something that exists in the world today. You want to use the car's display the infotainment display and the controls in order to play music on a smartphone app that you as a developer have built. So you could think of how, say, if you're using Pandora on your smartphone inside a vehicle. How is that actually working today? So let's take a look. It's usually pretty simple in terms of the logical architecture here. You have a smartphone, you have an app that's been developed to run that smartphone. There's a serial connection, usually it's Bluetooth, it can also be USB, that's interacting with the head unit. So we're going to look at an example from one of the automakers. In this case, we'll look at Ford's AppLink. They provide both an Android and an iOS SDK for developers. For Android, the developer adds the jar files that you get from Ford into your app project. And for iOS, the developer imports Ford's Xcode project files and then does the linking into the app project with Objective-C. So this is what this looks like. On the top line, you see the Android, and on the bottom line, you see iOS. And the use case that we wanted to accomplish is really simple. The idea is I'm looking at my infotainment center, and I want to press the OK button. And once I do that, I want the audio to start playing from the smartphone. So you see we're just doing a simple, essentially an event listener on button press, and we check to see that the button is labeled OK, and then if it is, we start the audio player. So it's pretty simple to see how you can actually get in and make the head unit interact. So to do the other more sophisticated stuff, it's just a matter of learning the rest of the API, which is pretty well designed in the same way that this software API is for the methods that you see here. That was application number one. Here's the second scenario. The idea here is you're creating a smartphone app outside of the vehicle. So the use case could be, for example, you've just landed at the airport and you're waiting at baggage claim. You like to pull out your smartphone and start your vehicle while it's parked outside at the airport parking lot. So how does that work? The scenario here is you have the smartphone device is talking to the cloud using an HTTP API that the car company has provided. So the car company is actually running the logic behind the API up in one of their data centers somewhere. And then on the other side of that, once, say, it gets a request to do something to the vehicle, in this case we're going to say start the car, it sends some sort of signal over the web down to the vehicle. This could be some proprietary protocol. It could be an SMS or MQTT, which is an emerging protocol for doing really small embedded system stuff. And that's the idea there. So GM provides a simple web API for developers to do this. So let's take a look. The developer registers at GM's developer portal, and they request an access token. This is in the same way, this works like any other web API would work from, say, Twitter or Facebook. You request your access token, and once you get that, you're just doing simple HTTP to actually make the method call, and then you're using OAuth 2.0 to handle the authentication part of it. So you can see here, this is the actual GM web API. It's a really nicely designed API. They've got the version number right in there. You provide your vehicle identification number, the VIN, and then you issue the command. In this case, the command we're sending is start. And just like that, your car will have started. So the third type is the head unit app. So this is the case where you're not necessarily concerned about having a smartphone involved, but you have a really interesting idea for how an app could work inside the infotainment center. So here, the idea is you are building an app that is running in the head unit in the same way that you build an app that runs right on top of a smartphone. This head unit will have access to the web, and you can then call your mobile backend through the cloud, just using traditional HTTP. So again, we'll take a look at GM because they've done a really fantastic job with this program. So GM provides an HTML5 and JavaScript Internet App Framework, and that also includes a really nice SDK with an emulator. The good news here for, I think, anybody that's looking at getting into this is that they didn't do any funky proprietary platform. They chose HTML5 and JavaScript, which is just a brilliant decision by the architects at GM. So how this works is, as a developer, you submit a developer agreement. They point you to the downloads for the SDK, and then you build your app while you're testing it with the emulator. And ultimately, once it gets approved, you submit it to the GM app shop. And the JavaScript looks like this. This is not too dissimilar from JavaScript that you would see in the browser. The first method is a quick synchronous call to get the actual vehicle speed, and the next two calls are actually asynchronous callbacks where you have a success or a failure function. And the second one allows you to figure out the radio info, which is what's the volume, what's the current channel that the radio is tuned to, and that third one is what actually allows you to do your web service request out to your back end. So for me, this is really interesting stuff that somebody who has enough savvy to build a web app with the browser can build an app that runs inside the vehicle. So the progress that we have today is really tangible. There's the stuff that you see from Ford for the in-vehicle case with the smartphone connected to the car, and the stuff that you see from GM, both running on the head unit and connected to the car remotely, is really exciting stuff. We've come a long way in just the past few years since the space started heating up. But what are the risks? And now we're going to switch a little bit and talk about this from the perspective of the automakers, because the risks are not insignificant. So the folks that we work with refer to this as the CNN moment. This is where you wake up in the morning, you're drinking your coffee, you turn on the news, and you see that some hacker has, say, unlocked every vehicle in a city, and a bunch of them were stolen. Or something happened with an app because the driver was distracted and an accident took place. There are real significant property and physical risks to the person that happen around this type of stuff. So compared to, say, building a Facebook platform or the Twitter platform, the risks here are much higher, sort of inherently. Not to mention that, unlike what most of us have done traditionally in the app and the web world, the automotive industry is a highly regulated industry, and there's a lot of hurdles to overcome there as well. So if we contrast it with a traditional software platform, when we build, say, a traditional web API that is going to access a web service and maybe it powers some apps, there are two key things that we need to think of. The first, which is the obvious one where most developers start, is the idea of the features. So you've got your API, there's a bunch of features laid out that describes essentially what the apps built upon the API or the platform are able to do. The second one, though, is around security, the authentication and the authorization for what the app and the app developer and the app developer's app's ultimate user have access to. Now, we've solved this to a large extent with three-legged auth powered by standards like OAuth, where you have three distinct parties. You have the consumer, in this case it would be the driver of the vehicle, who can decide which apps are not put in the vehicle. And then you have the provider, in this case it would be an OEM or a car maker like GM or Toyota or Tesla. And then you have the app developer who's creating the app that they want to put inside the head unit. So some of this stuff is already there. In fact, GM uses OAuth 2.0 as I pointed out earlier. The additional issue is this really important third vector around physical safety. An executive at Ford often talks about this as the 70 miles per hour problem, which is to say, when you're operating apps and infotainment systems in the car, it's all about the physical safety. It's a totally different scenario that's happening. So the way to think of it is from the app maker's perspective, the car makers, that is, they have to build sort of the ultimate sandbox if they're really going to make the platform story stick. They have to account for the same authentication problems that the app providers have, but they have to include this notion of physical safety. For example, if you talk, we were just on a recent trip to Germany talking to some of the car makers over there. It's really important that when you say you're going to control the way an app works, maybe if it's running on your smartphone, they want to encourage the app developer to put as much of that control into the physical knobs and switches of the car, because it's easier to use those in a distracted way, as opposed to, say, putting your finger on glass and making sure your finger's on the right spot without being able to get that tactile feedback. So it's a significant undertaking, and I don't envy the job of the folks who are working to get this right. There's another inherent issue, which is sort of just the fundamentals of the market. So if you look at the typical price point of an automobile, it's in the average in the U.S. in U.S. dollars, it's around $30,000. If you compare it to a washing machine, it's about $1,000, whereas a smartphone, once it's subsidized through the telco, the cost to the consumer is around $200. With that price point comes a certain amount of expectations around life expectancy. right now, the average car life expectancy is about 10 years. The washing machine is in the same order of magnitude, it's around 10 years as well. Whereas a smartphone has a 21-month cycle. So we have this collision here where the consumer expectation is coming from the consumer electronics world, where things can go obsolete in 2 years and the next latest and greatest thing is coming along. Where on the other hand, the automobile industry, because of its high price point, is moving at the speed of decades instead of something that's measured in 21 months. So that mismatch between what the consumer expectation is and what the automobile can do is going to create a lot of interesting innovation for the platform as well, especially when it comes to updating the software in a way that's easy for the user to do, not having to do the whole recall channel where the vehicle needs to go back into the dealership to get software updated. So there's quite a bit there to make sure that the frequency of the consumer expectation matches what's going to happen with the automobile. That's sort of a fundamental thing. And then there's the notion of culture. And this is also an interesting issue. So this is the value chain of traditional software world, the world of the web and the world of apps. So the idea here is you have a platform company, you can think Facebook or Twitter or Amazon. They put out an API and they market that API to application developers. The application developers take the web APIs and the APIs from the device and they build apps. The app goes out through an app store and then ultimately it's used by a human being who is the app user. Okay, so this is the world that many of us from the software and web side are comfortable with. The important point here is if you look between the platform company and the application user, the developer is in the middle. That means that the platform company is comfortable going from a direct model to an indirect model where there is an app developer who pushes things through some sort of app store to get to the end user. Now the next step is actually what the traditional car companies look like, and this is pretty much true around the globe. The model is more or less the same. You have a car company, and the car company relies on a set of tiers of suppliers. So in car jargon, the car company is the OEM, and they have tier 1 suppliers, and then those tier 1 suppliers have suppliers to them, which the OEMs call tier 2 suppliers, and so on. So often, the idea of an app developer, say, ringing the phone of Daimler to talk about getting their app inside the next version, one of the next models from Mercedes, is going to be a very difficult proposition because that app developer calling the car company directly does not look like one of the big major tier 1 suppliers. So that's sort of the first step, is how does the app developer get into this situation where there's this sort of really hierarchical set of tiers. The other more interesting problem from the perspective of the developer and the long-term view of the apps is the other direction. If you'll notice, the car company and the car dealer are directly interfacing with the customer. There is no intermediate step that's built into this model. So what this means is an example. If you think about when you're in your vehicle, if you actually did an inventory of all the parts and all the companies that supply all those parts, it's a staggering number of companies that are providing the capabilities that make that car work. If you notice though, there's typically only one brand on the product, and that's the brand of the OEM. It's the BMW, it's the Mercedes, it's the Cadillac. And that is deeply ingrained into the way that car companies work with their partners. There's one exception to this, which is the thing that we need to crack here, because our question is, how do we take the other part of the value chain that we think is interesting, which is the app developers and the car APIs, how do we sandwich those three components into this value chain? We know from our experience in the app and web world that it needs to look more like the app value chain that we showed a second ago. And there's one case where you can actually see this in automobiles, and that is in high-end luxury vehicles. There are occasionally the other brand that you will see is for the audio system. You might see it in a head unit, or you might see it, as I've indicated here, on the speakers. For those of us that are pushing on how this app platform world looks, this is the model that we need to follow. We need to show that this type of approach can work. And you're seeing it from many of the leaders now, when the leading car makers, that is, when you have your Pandora app connected to your vehicle, say through Ford's AppLink, you actually will see the Pandora logo show up on the display, right? So things are moving in the right direction. It's looking good. Ultimately, we want the value chain to look like this. And notice now that between the car company and the customer, we've wedged in the pieces that we need in order to make the app economy work for the car companies. So when we read this from left to right, how this ought to work is the customer picks and chooses apps from something like an app store made by a developer, built using the APIs from the car company, which then ultimately gets purchased through the car dealer. They buy the car from the car company, which is also backed by their traditional set of tiers of suppliers. Now, one of the questions that you hear a lot if you're in the community around telematics and what do apps mean for the car, there's two big debates. One debate is, should apps ever run in the vehicle? Right. So clearly GM's take on this with the developer program they have is that yes, apps will run on the head unit, and you build it in HTML5 and JavaScript. Another big question is, should the car makers have an app store? And if the answer to that is no, and some OEMs very strongly say the answer to that is no, and strategically it will be no for a long time, then what you're left with is the only apps that will ever make it into the car are apps that have already proven themselves in the world of smartphones. So what that means is Pandora and Rdio and Spotify, they're in the car because they happen to be successful on the smartphone. But there's a whole other class of apps that might be really interesting to the driver that wouldn't make any sense going through the hurdles of the smartphone world. So if you're ultimately going to wrap the context of all the sensors and actuators and computing power of the vehicle around the customer's context, then essentially you have to unleash the ecosystem that an app developer community could provide. And then the only way to really deliver that is through some sort of app store. It might not be gigantic like the app store you find from iTunes, but there needs to be some sort of expression of that app to meet the needs of the customer. So for me, this is what the beautiful stuff looks like in the future. Now, to put it in a little bit of a historical context, I won't claim to be an auto historian. There's some really smart folks who do that. But I see, in terms of the skill set that needs to exist within an organization, a car-making organization, to be successful, it sort of has changed over time. And the companies that have been successful, they put people in leadership positions in these companies at the right moment that had the right background. So if you look at the beginning of the car, the tinkering really happened in southern Germany, in Stuttgart and Bavaria, where you had Benz and Daimler and Maybach all working fundamentally as tinkerers, as inventors, creating the first version of the automobile. And then Ford came along, although he wasn't trained in an official sense as a mechanical engineer. He was with very strong mechanical engineering sense. He applied a lot of science to the creation of mass producing the automobile, and he had really smart people around him like William Knudsen to help make that happen. And then once he started that, people from Porsche and Toyota came to Detroit to figure out what that model was all about. But they were at the cutting edge of that. And then you think about sort of the next wave was what I call the Kettering wave. Charles Kettering, among many other things, he invented the first electric starter, where people no longer had to break their arms using the crank starter, and because his training was in electrical engineering. And once he did that, his company Telco became part of General Motors, and General Motors rode that wave of really strong, sophisticated features in their luxury brand Cadillac, which then made their way into the other vehicles over time. Now, the next wave started. I'm going to attribute it to the Galvin brothers. These are the guys who created the Motorola company. Now, Motorola was started to bring the consumer electronics product of the radio into the vehicle, which was a pretty profound idea at the time. And that sort of mindset of seeing what's happening in consumer electronics has been around for about half the life of the automobile industry, about 50, 60 years. Motorola was also trying to bring another consumer electronics component, which was the telephone, into the automobile when they created the mobile phones that we have today, which in this interesting virtuous circle are now driving the next wave of innovation. From what I can tell, I think all automobile companies are solidly with leadership in this electrical engineering phase, where they have smart folks who know how to do systems and process applications with electronics. The leading edge folks are leaning heavily into the consumer electronics space and know how to do this well. But I think there's only one company that's inherently set up for the next wave, and I think the next wave is all about software platforms. Because once you get the hardware right and you create that sophisticated sandbox in a way that you've taken care of the features and the security and the physical safety, then all the lessons from the software world come in. And I think from what I see talking to car companies around the world, they're bringing on the right people and putting them in the right positions to make this happen. But when you look at Tesla, which is led by Elon Musk, he is fundamentally a software platform guy. They built PayPal, which is one of the most important APIs we have in terms of actually making commerce and transactions. So it's inherently in his DNA, and he's the guy running the entire company. So I think it's going to be interesting to see how this plays out if Tesla takes the leadership position and how the other car makers evolve. So here's a quote from Ryan Sarber. He's actually leads Twitter's platform, so he's responsible for their API and all the developers that use it. And I asked him what his take was on how he viewed the programmable car, and this was his take. APIs make cars a software platform, not just a hardware platform. That is where the high-velocity innovation is going to happen. Running a platform is like running a small town. A lot of it is about governance and policies. Very little is about the tech. The most valuable platforms provide a large audience, plus user acquisition or unique data. Cars have the potential to offer both, and I think that's a very well put point. Now, running a developer platform is difficult, and I like to give one example. This is especially for the car makers on the phone, why running a developer platform is so difficult. Because it's really about winning the hearts and minds of the app developers. And as soon as you talk about winning somebody's heart, it becomes a really irrational exercise. And I'd like to show you an example of this that just happened recently. This is a tweet that became, this is one of the retweets that I was able to find. I couldn't find the original post. But this tweet became very popular. It says, "Nice, we can now hack cars. Thanks Tesla Motors. Tesla Model S REST API with a link to the API documentation." If you notice, this happened back in February of 2013. Now, when it comes to getting somebody's mind fired up, why would a developer be fired up about a car API? You would look at the data, right? If you look at vehicles sold in the first quarter of 2013, Tesla sold 4,900 vehicles. GM, on the other hand, sold essentially 2.3 million vehicles in that same time period. So if you're just an app developer thinking rationally about which vehicle platform you should target to build your app, you would say GM. Now, the heart, though, says, oh my God, Tesla has an API, because people love the brand of Tesla. Developers love the brand of Tesla. And this is the lesson that, as Apogee, we give to all of our Fortune 500, Global 2000 customers, is that your brand working with the developer is just as important as your brand working with your consumers. So, whether you're contrasting, if you're a developer, should you work with the Amazon API or the Sears API? Should you work with the Blockbuster API or the Netflix API? Those brand questions are as important for the developer as they are for the consumer, and we're seeing it again here with the vehicle. So my point here is, oh my gosh, Tesla has an API. The only problem is they don't actually have an API. What happened was a developer reverse engineered the API by looking at the calls, the HTTP calls that the Tesla app was actually making. Tesla hasn't launched the public API. They don't have any documentation. They don't have a developer portal. They don't have any of the things that GM and Ford have had for like over a year now. GM and Ford have had those things, and no one really talked about it. But Tesla has one guy reverse engineer it, and it hits Twitter, and the whole developer community gets really excited about it. And this is exactly, if you're running a developer program, this is exactly what you want to have happen. This is how you win the heart of a developer, and a lot of it comes back to understanding how your brand is going to resonate with that developer community, which takes us back to that value chain. It's really important, if you're going to think as a platform company, you're creating two sides of the market. You're creating a side that benefits the developer, and you're creating a side that benefits the consumer. And it's important to put that developer between the car company and the consumer. So people, I wasn't going to include this, but it came up as I was preparing for this. People want to ask, what is Apogee's role in the programmable world? So I apologize. I'm going to give you, this is our quick little bit of a commercial. You can ignore it if you're not interested. But this is where the Apogee capabilities fit in this world of the programmable car. Starting from the top, again, we stress that the most important person in the value chain is the application developer. So we have a whole set of capabilities that we call the developer channel services that allows a car company to get app developers on board using their portal and get really excited about it. If you look at the GM developer program, that's actually something that was powered by Apogee. That's something that runs in the car company's data center. Along with that, we have something called app services. So this is something that would be used, say, when an app developer is building a smartphone app or an app inside the head unit, and they want to store the data somewhere, they use app services as their mobile backend as a service. And you can do this in a couple of ways. One, you could just let the app developer choose whatever backend they wanted, or as a car maker, you could private label app services and provide that as sort of a sanctioned way that app developers can store data in the cloud. And that will help you, because there'll be plenty of privacy regulations that the government is going to put in place, they have already, around storing sensitive vehicle and location data with cars. So this is another aspect that Apogee provides. On top of all of this, we have, of course, you're making a lot of requests to the cloud. You run those through the API gateway, and of course you provide analytics on that. Another part of our offering is something called mobile analytics. And mobile analytics actually runs on iOS and Android. And as things develop and get more sophisticated with the head units, some car makers are planning to choose Android as the foundation. We'll also be able to run mobile analytics on the head unit, which will allow both the app developer and the car maker to get visibility into how the app is being used. Great. So that wraps up what I wanted to talk about. If you think of the contrast, it's really interesting. You know, cars used to be about slinging axles together. Right now, where I'm doing this webcast, I'm just 3 or 4 blocks away from where Henry Ford had his first shop, where he built his first automobile, and it didn't look too dissimilar from the photo that you see here. Nowadays, the whole idea of how apps and cars are going to be built, it looks a lot more like this. This is the Ford Developer Program portal, where it's all about getting app developers on board to make the cars cooler for customers. And if you put it in a broader context, there's a lot of work being done around the Internet of Things. A lot of thought leaders are thinking about this, and from my perspective, the car is one of the most compelling components of what the whole world of the Internet of Things will look like. So now we'll open it up to questions. I know there's a bunch of chatter that's been going on, and I'll try to catch up with some of it. Where can I get more info links for the GM JavaScript head unit apps? If you go to developer.gm.com, you register for a developer account. It's all self-service, it's free. You just agree to their terms of use, and then you'll have access. You can download the SDK, or you can browse it on their website. Is there an emulator to test apps? Yes, GM provides an emulator to test their apps. Okay, does GM have it? Yes, GM has an emulator. Without an app store, how does GM market its HTML5 JavaScript apps? GM does have an app store. They call it the GM. Actually, it'll be branded per brand, so it'll be Buick, Cadillac, Chevy, etc. App Shop, where people can get their apps and download it directly to the head unit. Ford uses iOS Play app stores. Yes, so Ford's model is just the second use case. The first use case I talked about, which is bringing the smartphone into the vehicle and pairing it with a serial port, Bluetooth or USB. That's their entire model. They don't have the head unit model or the remote API model from a developer platform yet. What's your take on the two models, head unit versus mobile? I think all three of these models are going to be in play, because just like if you were doing hardware hacking in Arduino and you had one set of sensors for one app and another set of sensors for another app, each use case has requirements that are important to drive. So I think you're going to see the head unit, you're going to see the mobile device within the car, and the mobile device without the car. And all three of those will grow over time. Where do you see the market moving towards? I think the real trick is, Tesla doesn't have a developer program yet, and I really think that because of their brand cachet out there back in Silicon Valley, as soon as they make a move, a lot of people are going to stand up and pay attention. Also with the luxury brands, Cadillac, BMW, Lincoln, Mercedes, when those guys make moves, it's going to be important. The most important move clearly is to nail the app store and to put the app developer between the car company and the consumer. That's going to be the one where you know this stuff is real. Right now, frankly, if you look around, there are only 2 developer programs from car makers. There's Ford and there's GM, and there's nobody else. I mean, that does give you a lot of the market. I mean, GM is the #1 car maker. They go back and forth with Toyota, but they're the #1 car maker in the world. So the fact that they're there is really good news in terms of having an addressable market built into your vehicles. Which automakers are currently seriously considering Android as the in-vehicle platform? I'm not at liberty to talk about the ones that are. But GM, for example, is the only one that's made the bet on HTML5 and JavaScript. I'm sure they'll also consider Java things. In fact, they might already. There might be some stuff there that they've done with Java and Android. But my hunch is a lot of the other car makers are going to go into Android in a serious way. If are cars really hackable? If so, how can they be protected? Yeah, this is the #1 problem, is making sure that the cars are not maliciously hackable, but are allowed to be creatively hacked in a way that accrues value. And so we can do a whole other thing about security, but essentially, for example, GM has chosen OAuth 2.0 and then a whole bunch of other security measures around that. What kind of a browser runs in the dashboard? I don't know what the kernel is of the browser that GM has chosen. But as you can imagine, because there's so much unique capability in that browser, say, versus your typical web browser, I'm sure a lot of it is built by GM. There's a percentage of cars on street nowadays capable of being programmed. Okay, so what percentage of cars on the street now are capable of being programmable? I don't actually know the percentage, but the raw number is clearly in the millions. Like every car that GM sold last quarter, that was 2 million cars, they're going to be capable of being programmable because they ship with OnStar. So that's going to make it programmable. Do you think Google or Apple would ever enter the car OS market? I think Google is in the car market clearly with the Google Car, the autonomous vehicle. They are the guys behind Android. The CEO and founder of Google is a Detroit guy. His grandpa was a GM employee, and he's passionate about cars. So I think Google will be in there very seriously. Apple's already partnered with GM to do stuff around Siri. So I think those guys are going to, in earnest, they'll be entering this market shortly. Ramesh, I'm an Android developer looking to integrate my app with Ford Sync App Link. One of the hurdles is they won't pass the utterance to Android. I'm not sure. I don't know enough details about that. It'd be interesting to see if you get good support if you ask them on their developer portal. Alex asks, what can the industry do to stop car hacking? I think they have to learn everything that we've learned from the web and the world of apps and leverage that into the automobile. And I met a lot of these guys. We've got smart guys in the Silicon Valley. There are really smart guys in the car industry too, and they know what they're doing. And I think they've got it. Speech recognition. Actually, this is a really interesting one. Along with just the physical gestures, there's an API, for example, in GM in the head unit for speech recognition. Passing what the head unit hears into something that your app can react to, and that's in the platform. John Sanders asks, will access to diagnostic information be available? I think someone pointed this out in the chat up above. Ford has a really interesting project. I think they call it OpenXC, where you can plug a hardware unit into the diagnostics unit of the vehicle to get a whole bunch of information, and then some other information I think is available through most of the web APIs from GM and others. Can one build paid apps on either GM or Ford platform? I don't think you can do that. Ford doesn't really think of themselves as a platform, I don't think. They think of AppLink as something that plugs into the iOS and the Android platforms. So there's really no way to monetize Ford. GM, I think with their app shop, that's exactly where they're headed. Nick asks, do you see in-car displays becoming dumb displays in the future when a recognized mobile device is present? To an extent, Ford AppLink does that already. I think Ford's strategy, as far as I understand it, I think it is in that direction. I think the far more compelling thing is GM's direction, which is making this display even smarter and more programmable. Because there is debate in the community, and I don't claim to be a core part of the community, but from my perspective, developers love sensors and actuators, and they love a stronger and richer and more robust API. And the fact that you could have a smart display with smart controls, but then not be able to program against it, it just doesn't jive with the reality of how programmers work. And I think if you get the developer between the car company and the consumer, it's not going to jive with the way the consumer works either. So I really think the car displays are going to get smarter and smarter. Ramesh asks, with hurdles like that, where developers have to depend on the auto platforms to evolve to keep up with mobile platforms, do you see this as always one step behind? I do definitely at the beginning. I think the car makers are going to inherently be one step behind. But the optimist in me tells me that once they figure out how to treat the car as a software platform, then the hardware will have a 10-year life expectancy, but the software will start working at the same cadence that the consumer electronics business does. And once that happens, again, because it is its own unique set of sensors and actuators, it will attract a different segment of really smart engineers and software developers to it. I think the apps will be on a cadence that's completely independent of the smartphones, and we'll view them as two totally different branches. A question from Oleg: what standardization effort in automotive APIs platform is worth following? There's one from Ford, contributed a bunch of open source stuff. I think it's called Genivi. I think it's Genivi. That is worth checking out. The OpenXC stuff, also from Ford, is worth checking out. At Apogee, we're working on sort of the web API part of this. For example, if you build an app, or say a remote app, that say could lock the car doors, unlock the car, start the car, shut the car off, give you a readout of how much battery is in, how much charge the battery has. You wouldn't want to build that app for every different car maker out there. You'd like to build that app once. So we're working on creating an API exchange where you could talk to one API, and then that API would in turn talk to the proper car maker on the back end of it. That's more future-looking stuff. That's stuff we're doing in the lab. Paulie asks, do you see the potential of responsive web design being applied in cars and it becomes considered another device? Absolutely, I do. In fact, GM has, if you download their SDK from their developer site, you'll notice they have in the world of, this is where we have mismatches in the two industries. In the car world, they call it HMI. In the app world, we call it the UI, but it's the same thing. It's the human-machine interface or the user interface. They've done a really nice job of providing guidelines about how you should, create the apps for the head unit. And I think the smarter people we have doing responsive web design, applying that to the vehicles, the better off we'll be. Because for the most important reason is safety is at a much higher premium in the vehicle than it is when you're holding your smartphone. Do you think Microsoft will be moving in the market? They already have. Microsoft they're the folks behind Ford's software, essentially, their core in-vehicle software for sync and app link and so on. So yeah, they're definitely in there, and I wouldn't be surprised to try them grow. Another player is in there. They're called QNX. They're actually owned by RIM, the BlackBerry guys. Oh, actually, they're BlackBerry now. I'm pretty sure they're a wholly owned subsidiary of them, and they have a Java platform and also a JavaScript and HTML platform that they sell to the car makers as well. So that's worth checking out. What about the Toyota Intune system? Yeah, that's as far as I know, it's a similar strategy to the whole idea of linking the device to the vehicle. It's not about a core platform. Boy, oh boy, I'm running out of breath here. Mark Hillman asks, with Ford deciding to put a cell radio in the car, it seems they would go the way of GM with open app approach. I sure hope so. I have to agree with you. If not the open app approach on the head unit, at least a stronger developer program around the remote case where I can unlock the car, start the car remotely using web APIs. Yeah, and you're pointing out a good point. GM just also, they did a deal where GM cars in the future will be shipping with Verizon 4G in every vehicle, which is going to be fantastic bandwidth in the car. Okay. So Alex asks, what sort of data connectivity are needed in cars? Yeah. So the cars themselves are going to increasingly have 4G. It will express itself as Wi-Fi in the vehicle, but you definitely don't need Wi-Fi in the car. It would be very difficult to do because it's usually moving when it's most interesting. Eugene asks, a lot of web APIs that would be compelling to use in-vehicle apps are OAuth based. Unfortunately, OAuth requires an actual general purpose browser to authenticate, something that in-car platforms don't provide. Has any thought been given to this? Well, actually, in the case of GM, for example, they do have the in-car general purpose browser to do the UI step of it. OAuth 2.0 actually gives folks a lot more flexibility in the way that the authentication scheme works. So I don't think that that's going to be an issue. Corey asks, what are the typical car info controls that are exposed by API? Any site where I can see a car app demo. If you check out GM's developer site and Ford's developer site, their documentation is really clean, and you can see all the APIs that are available. And then the fun thing, it's a really powerful API to begin with, but the fun thing to do is then look at the list of APIs and then look at the list of all the sensors that are in the vehicle, and you'll see there's a lot of really interesting places to go. If you think about, if you're a developer and you know that for any modern vehicle today, for the fuel injection to work, they have to know the barometric pressure. For the windshield wipers to be on or off, you can get a sense of what's happening with the rain. And there's a whole bunch of sensors that are there that will eventually be exposed to the API, and some really cool apps can pop out of that. Who will standardize all these car APIs? I think the software, the in-vehicle APIs, it's too early to standardize them, and I just don't think there's enough value there right now, in the same way that iOS and Android will probably never standardize on their software APIs, and I think that's completely acceptable for a developer, as long as they're using mainstream languages like Java and JavaScript and Objective-C. It's not going to be an issue, but I don't think there's any reason to standardize the software APIs because it's just too close to the vehicle. Now, standardizing the web APIs, I think that's different because it's a smaller set of things, and it's much easier to standardize that stuff because it's just simple HTTP calls. So I think the web APIs I think could standardize first. Oleg asks, what is your opinion of the role of telco providers in the automotive ecosystem? Just data pipe or more? I love this question. We work a lot with telcos around the world and with auto companies too now. And automotives, the good news is automotive OEMs, they view telcos as a tier 1 supplier. They have direct relationships. So that's a fantastic spot for the telcos to be in. Now, the challenge for the telcos is how do they get developers fired up about working with what the telco is providing to the consumer, and that's where the challenge of data pipe or more. I don't have a strong opinion about it that I can express here at least, but I think there's some cool stuff that can be done. Great, thanks for all your questions, and stay tuned. Like we mentioned at the beginning, we will provide this video and all of our videos on YouTube. It's at youtube.com/Apogee. We encourage you to check out our Google group called API Craft. And anytime you want, you can contact me directly. There's my email. It's brian@apogee.com, or you can hit me on Twitter. Thanks a bunch for tuning in, and we look forward to talking more about the programmable car and helping this thing happen. Bye.